Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to solve this double integral from 0 to 1. Integral from 0 to 1 square root of x plus square root of y over square root of xy times 1 minus xy dx dy. Well, how to begin? Okay, first here we have integral from 0 to 1, integral from 0 to 1. Then in the numerator we have square root of x plus square root of y times, now we know this part square root of xy means xy to the 1 over 4. So we can write xy raised to the minus 1 over 4 over 1 minus xy. Now here dx dy. Then as a next step here, integral from 0 to 1, integral from 0 to 1 square root of x plus square root of y. Then we know this part we can represent as an infinite series by using geometric series. So we have k is equal 0 to infinity xy raised to the k minus 1 over 4 power dx dy. Okay, then we can simplify. So now we can write here this is equal to, now we can interchange integral signs and sigma notation. K is equal 0 to infinity integral from 0 to 1, integral from 0 to 1. Now square root of x means we know x to the 1/2 power, so x to the 1/2 power times xy raised to the k minus 1 over 4. Then square root of y means y to the 1/2, so y to the 1/2 times xy raised to the k minus 1 over 4 times, now here dx dy. Okay, then we can integrate. Before it we can simplify this. So we can write here sum of k is equal 0 to infinity integral from 0 to 1, integral from 0 to 1. Now if we simplify this here, x to the 1/2, x to the k minus 1 over 4 power. So we have x to the k plus 1 over 4 times y to the k minus 1 over 4 plus if we simplify here x to the k minus 1 over 4 times y to the 1/2 plus k minus 1 over 4, so k plus 1 over 4, and here dx dy. Okay, then here k is equal 0 to infinity integral from 0 to 1. Now I am going to integrate with respect to x. Integrate with respect to x. So we have here x to the k plus 1 over 4 plus 1 according to general power rule of integration. So here x to the k plus 5 over 4 over k plus 5 over 4 times, sorry, here 0 to 1 times y to the k minus 1 over 4 plus here if we integrate we have x to the k plus 3 over 4 over k plus 3 over 4 from 0 to 1 times y to the k plus 1 over 4 here dy. Well, then if we apply limit boundaries, now we have sum of k is equal 0 to infinity integral from 0 to 1. If we apply limit, lower limit 0 and upper limit 1, so we have 1, so y to the k minus 1 over 4 over k plus 5 over 4 then plus here y to the k plus 1 over 4 over k plus 3 over 4 here dy. Well, then we can integrate with respect to y. So we have k is equal 0 to infinity. Now, if we integrate y to the k minus 1 over 4 plus 1 over k minus 1 over 4 plus 1. But if we apply limit from 0 to 1, we have again 1. So we have here 1 over k plus 5 over 4. Then k minus 1 over 4 plus 1, we know 3 over 4. So k plus 3 over 4. Then here we have 1 over k plus 3 over 4. 1 plus 1 over 4, we know 5 over 4. So k plus 5 over 4. Well, then we can simplify. Here sum of k is equal 0 to infinity 2 over k plus 5 over 4 times k plus 3 over 4, because we have same denominator. Well, as the next step, we can find the Facet fraction. So here k is equal 0 to infinity. Now we can use the cover method. So we have here 2 over k plus here k plus 3 over 4. So when we plug in minus 3 over 4, we have minus 3 plus 5, so 2 over 4. So we have 1 half. Then here k plus 5 over 4, so minus 1 half, so minus 2 here 1 half. So we have 2 so 4 times sum of k is equal 0 to infinity 1 over k plus 3 over 4 minus 1 over k plus 5 over 4. Okay, then we can use the series representation of digamma function. In a previous video, we discussed about the series representation of digamma function. So if you like to watch that video, I will add the link in the description. So we have to convert this sum like here 4 times k is equal 0 to infinity. Here 1 over k plus 1. I'm going to add 1 over k plus 1. Then here minus 1 over k plus 5 over 4. Here 4 times. Then minus sum of k is equal 0 to infinity 1 over k plus 1. Then we know this k plus 1, this k plus 1 get cancelled, so no matter. Then minus 1 over k plus 3 over 4. Okay, now we know here this is digamma function representation. So we have digamma of here 5 over 4. So 5 over 4 minus digamma of 3 over 4. Okay, then digamma of 5 over 4 we can write 4 times digamma of 1 plus 1 over 4 minus digamma of 3 over 4 we can write digamma of 1 minus 1 over 4. Okay, then we have to use some properties of digamma function. So we know digamma of 1 plus c is equal to 1 over c plus digamma of c. Also digamma of 1 minus c is equal to digamma of c minus plus 5 times cotangent of phi c. In the previous videos we proved these identities. So now I'm going to subtract this identity. So we have digamma of 1 plus c minus digamma of 1 minus c. We know digamma of c get cancelled, so we have 1 over c minus pi times cotangent of phi c. Okay, then if we plug in 1 over 4, we have here digamma of here we have 1 over 4, so digamma of 1 plus 1 over 4 minus digamma of 1 minus 1 over 4 is equal to 1 over 1 over 4, we know 4, minus pi times cotangent of 5 over 4, we know 1. So we have 4 times 4 minus pi. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.